So now go ahead and make what we did last time. Just do this the screen half and half. So you have Rhino on one side and Grasshopper on the other side. For the most of the class, probably we will just do everything in Grasshopper, and we just watch Rhino this time. So just shortly, I assume you already know what is Ladybug, but just again shortly, what Ladybug does is it's mainly helping you to import and analyze weather data. And again today, similar to the last class that we had, the idea is to show you the workflow more than really doing like starting a problem, finishing it done. I want you to learn how to think, like how you can use this tool basically. That's the concept. And we're going to use the example files from Ladybug group. So just go ahead and download the example files. So again, the same page up there, it says example files for Ladybug. And how you can download all of them together. I think if you press download up here, are you sure you want download? Yes, okay. It just downloads all the files. $760 kilobyte. Wow, I have so many questions. We can't answer the questions, but hopefully you can hear, right? Okay, you can hear perfectly. That's fine. Okay, so now you have the example files. Go and extract the files somewhere on your system. We will go back and forth like multiple times. Just put it somewhere that you can easily find it. I think I downloaded it for you, Rami, right? It's in your download folder. So you just copy it somewhere else, so we're not using the shared files, so we don't get these issues of like, just make your own folder. I make my own folder. This is fine. So you take your own folder. Don't take my files. So now you should have 8 different files, right? Hopefully we will get like to file 5. If we can do it to up to 5, I'll be extremely happy by the end of the class in 4 hours. Well, we already 23 minutes in. So go ahead and open the first file. Again, you can do it in different ways. You can just bring it here, getting it started. Or if you don't like this way, you can go File, Open, find wherever you have it, go inside the folder. Oh, I said I'm not going to use this. Go inside the folder and open Getting Started. If it gives you this message, like which it gives me, because I'm using Grasshopper 72, but at the school we have 64, which is an older version. So just disregard this. Would you like to see them? No. And it should be fine. I hope. Yes, it is fine. Before I get started, 2 things. One, zoom in and make sure this thing tells you good to go. If it doesn't tell you good to go, it means your units are not meters. I opened 0, the first one, Getting Started. You're good to go? Everyone? Okay. Just make sure. And then, so here is how the structure of Ladybug is. You get Ladybug, which is basically the basic stuff, like open the weather file, bringing some data in. Then you have Analyze Weather Data, which gives you the ability to do basic analysis on the weather data, but it's not going to be visual. It's basically data management. Then from here, it gets a little bit more interesting. You visualize weather data. It's radiation rows, a sky dome, we will go there, like wind rows. And then you can draw sun paths. And I hope we can finish up to the sun paths before the break. And after that, we can work on the radiation analysis, sunlight average analysis, and we do some ray tracing. But what will happen in reality is we don't get to the sun pass before the break. So after the break, we work on the sun pass and the radiation analysis afterward. I try to stay positive. So these files are already set for you, so you don't have to do anything. But while we are going there, I will ask you to bring down some of the stuff and all the things, so you can do it on your own later too. The first component that you always need to use in Ladybug is Ladybug, which is this component, which is the heart of Ladybug. Basically, it has everything included, like all the functions, almost all the functions are inside this. If it works fine, it should be flying in your system. Is it flying? Okay, making noise. That's a good noise. So the next thing that we need is we need to have a weather file before doing an analysis. So you need to go and download a weather file. The weather file that Ladybug uses is an EPW file, which is energy plus weather file. I assume all of you know what is an EPW file. Okay, so just go ahead and press this button. What this button does basically is it opens up your default browser and it comes to this website. It's equal to going to the Google and say EPW weather file. And again, I assume you all know about this website, kind of. Okay. So just go ahead and download one of the weather files that you really like somewhere. I mean, all of us can do the same city, or we can do different cities. It doesn't really matter. I think if you do different cities in some way, it's interesting because you get different results from what I have here. But at the same time, it's a little bit harder to follow. Just it's up to you. I would say take the risk. Just select something that you like. So I go to the North America, USA, and then I download Chicago. You go and download wherever you like. Chicago O'Hare, zip file, save file. Open wherever you have the file zipped. Go and open that. And am I going so fast or is it fine? So you can follow. Okay, just open these files and extract them in a folder. Extract them in Mustafa. Again, Rami and Josh, don't use my files. Check yours. So I put it in the same folder. So first of all, I want to show you something here. When you download the files, you get 3 different files. It's not only an EPW file, right? Have you ever opened the other files? You did, so you should. So right click and open with as hello. Okay, I do it again. So open it as a text file. So there should be a stat file, and this one is a DDY file. Open with Notepad. So this is a stat file, which is maybe, sorry, this is a DDY file, which is not maybe the most useful when you look at this, but it has so many data like that you may want to use for your energy simulations. We probably talk about this like in not even in the next workshop, maybe after that if we want to do some energy simulations. But go ahead and open the stat file. If I can find open with, select the program from list, Notepad. So in this file, you basically get many of the data that you want. For example, many of the stuff that you use Excel for, you don't need to do that. Like the average weather data that you want for the temperature, heating degree days, cooling degree days, like the average monthly wind direction, all this stuff is here. I think it's a pretty useful file, and I have seen people using EPW file plus 4 hours of work to generate whatever is here, and they usually make a mistake. So it's 4 hours plus fixing the file that you have. So take a look. It's not something that we want to talk about like in this class, but just for your information. But what we want really to use is this file, which is an EPW file. Do the same thing, right-click and open this as a text file. I want just to show you how it looks. Have you ever seen it? First question. So you guys all seen, you know how it is structured? If you know, we don't need to do that. Let me do it. I mean, yes or no? I can't hear you. Okay, no, okay, we have just nodding. Okay, this is how the file looks like. It's basically a CSV file, comma separated values. And as you look, it's not the easiest thing to read, but it's not that hard to read too. So here you get the location data. It tells you in Chicago. There is something going on about latitude, altitude, all that stuff. Then it tells about the design conditions. Then it comes down here, and this is the first hour of the year. So each line after the data here is basically a single day of a single hour of the year. And as you can see, this data for the file that I have is selected from 1986. And then in each different segment here, you have some kind of data. So what Ladybug does is basically comes inside in this file and read the data from this file and bring it to Grasshopper. As simple as this. Okay, fine. So now you guys know what we're talking about. You have it downloaded. Let's go and open it. To open the weather file, there is a component here. Comes from here. Cause Ladybug open EPW weather file. So double click on this toggle. It will open a window and just go to wherever you downloaded the file, and you should be able to open the EPW file. And if you do it successfully, if you connect the panel here, it should give you the address, right? Doesn't work. If you double click, Okay, I'll show it again. So this thing is in false, okay? Go here, double click. It will open a window like this. Double click doesn't work. Okay, let's do it easier. Just, what about this double click? No double click on your system doesn't work? Okay, I gave up. So go up here. I mean, we should find a way. I don't know even where that thing is. Give me a second. File path. So okay, go here. Params, like parameters, and then primitive and file path. Bring this thing. So go to parameters here, primitives. There is a file path component. Bring this thing here. Hopefully right-click works at your systems. No, your mouse, is your mouse connected? Do you guys want to restart and open it up again like this? All of you guys can't press right-click? You're the same? Okay. That's interesting. That's the first time. So you guys on this row are fine? Okay. That's so interesting. Double click bug. Okay, it works. Just restart for the ones that... Find it. Okay. If you got double click to work, that's fine. If not, you can do it. This component basically does the same thing as what you can do with path. You can right click and set one file path. The only thing is that this one filters the EPW files for you. So if you remember when I did that, it only showed me EPW files. You see, like it doesn't show all the files. When you start, it's helpful because you can easily get confused, open a stat file or DDY file. But after a while, when you get comfortable with Grasshopper, I personally always use this one. Just use the file, open an EPW file. It will be the same. So all you want to get is basically this address. Even if you type this address in a panel, they're all the same. As far as you have the address, just connect this address here and connect the valid, okay, because I didn't load it. Connect this one here and the magic happens. Okay, that's it, I'm leaving. So, did you get it? Path, mine, I use this file, but you can do the same thing. So I just do true, select this one, open, you connect it here. So what happened is this component basically did what I showed. It goes inside, it reads all that lines, and then it outputs that data. So now the output that you had inside a text file coming to Grasshopper. So here basically there is a key file, it says it's from Chicago, it says this output is a dry bulb temperature, the units are centigrade, it's hourly data, it starts at the 1st of January at hour 1, it ends in 31st of December, hour 24. And this is all your data, 8760 hours. Make sense? Okay, now you got all the files, all the data here. Let's look what you can do with this data. The first thing that you can do is the simplest stuff that you can do with any kind of data sets in Grasshopper, right? For example, what you can do is you want to know how many hours the temperature is more than 24. What I need to do is I just use Grasshopper, right? Let's say you have some numbers. How do you do that? You say bigger than 24. Larger than 24, and then you connect your numbers here, it gives you an error. It says data conversion failed from text to numbers. But if you look here, it still gives you some stuff. What's happening is you see for the first 7 items, it has an issue, and it is because the 7 item outputs from this component are basically our text or our strings. They're not numbers. So to deal with this issue, if you go up here, Ladybug, extra, there is a component that separates the text from the numbers. So here, separate data, connect this output from dry bulb temperature to this. It will output numbers as one list, and it will output strings and another list, right? So I went here, extra, up here, Ladybug separate data, I put it down here. So now I can do whatever I want with the numbers and whatever I want with the string. Now if I did it with the numbers, and as you saw, I did something, I didn't connect any 24 here, right? But it already has the 24. And the trick to do that was I just typed larger than, and then I typed 24. So it basically takes it as the second input. Sure, I can do it 2 times. Open larger than 24. Press enter. So now if I go and hover my mouse on B, it's 24. So it's similar to do this. Type larger than. I assumed you watched the tutorial, so you know one of the ways of adding a number is go here and set number to 24, right? And say commit changes. So now here I have 24. You can do this for many other components, and it usually helps you to be way faster. For example, you want to say something +2, you just type +2, or you type -10. What happens is the second number is 10. The second number here is 2. I mean, it's totally fine if you want to double-click, bring this thing, then double-click here, type 24, then bring it here. And again, what I did here, I didn't go up there, bring the panel. I just double click. I didn't even type a panel. I did double quote and then 24, right? Okay. Now, what was the question we asked? We asked like how many hours of the year the temperature is more than 24. Up here. Find it? So now if what I need is the length of this list, right? How many true? So if you check the output of this list, it gives me false, and at some point it should give me true. So what I want to do, if I can count the number of trues, basically I know how many hours of the year I have the temperature more than 24. How do you do that? Do you have any idea? Anybody now is a grasshopper expert? In a level of, how do you do that? You just count them one by one? That's one way. 1, 2. But so you can do one way is, if you remember, I showed dispatch last time. This is one way. So what dispatch does is it takes a list, and then based on a pattern, it separates the data. So whatever is true goes here, whatever is false goes here. So if I connect my numbers to dispatch and then use my pattern, use the pattern, and then so whatever goes to A means it satisfies this condition. It's a pattern, and I'm using it over and over so you learn how to use it. So if I want to say if something is bigger, or if something is smaller, or if anything, what I do, I bring that condition here. This thing generates true false for me, and then I use this true false as a pattern to separate the data, right? So if I check here, it says 1015, the number of values, but there is a component for that, which is list length. So just type list length and connect this thing here, and I connect this one here. So it tells me the number of hours that I have which temperature is more than 20, was it 24? 24. But there is another way to do it, which is way easier. So in binary, true is always 1, right? And false is always 0. So if I add up all the outputs coming from this component, for every true I get 1. For every false I get 0. So if I add them up all together, it should give me the same number. There is a mass addition component for that. So I just bring this thing here, and this is the same, right? So what this component does is basically adds up all these numbers together. And for false, it's 0. For true, it's 1. So it's just like one less component. Make sense? Sometimes you can do the other thing. For example, if you have a condition and you want to understand if there is, we want to know if there is any day that radiation is exactly 1,000. Probably it's not going to happen, right? So how we do that is we go here, and let's check the global horizontal radiation. So again, back up. Like what I'm trying to show you here is how to ask questions. You know, you have weather data, like, okay, you have weather, there are some numbers. What matters is to know to ask the right question, right? So this is how you ask a question. You ask like, how many days I have this, or how many hours I have this, or which hours of the day the temperature is more than this, all this stuff. And then as soon as you ask these questions, you want to deal with this number. So what question I ask, do I have, how many days in the year I have like radiation of exactly 1,000? Why? I don't know, because Rami is designing something with Arduino, and whenever it goes to 1,000, it was like, it wants to ring him. So, right, so you don't want to know like how much is the possibility of that. And then we think that's not a good idea, we change it. But how I do it, just check here. So again, I use the same component. I just Control-C, Control-V. This time I grab direct, let's go for normal radiation, which probably won't go to the 1,000. And then, so I connect it here. Now the output here is my radiation values, right? So I asked if it is equal to 1000. So I type equal to 1000, right? I connect the numbers here. Again, this thing is 1000, right? Now, the output of that component is what? Control C, Control V, one of the panels. The output of these components are true, false, true, false, true, false. And I guess I should be really unlucky if we get like exactly 1000. But how do you know that you have an average which is 1000? Again, you just mass addition, right? Yeah, that's what we will get. So I just add this thing here, and it will give me 0. It means it satisfies 0 average of the year. But what if you want to see the numbers? Then you want to put them in a graph, and this is where a component like this comes in. This component calls quick graph, and how do you find where that quick graph is? You click on this, Control Alt, right? Control Alt, click. If you have a newer version, it won't be here in utilities, I think, anymore. There is another new tab, but it doesn't matter, so you can always find it, right? So what this one does is basically it inputs the number, you input the number, and it gives you some lines. It's not, I'm not happy about this component. It doesn't have legend, it doesn't have numbers, you can't change the colors. The good news is like at my colleague at TT, she's developing some new components so you can plot really advanced charts. It will be out pretty soon. Okay, so you learned these parts. You know how to deal with data. So there are some stuff that are so common in weather data analysis, like what? Like calculating the humidity ratio, enthalpy, partial pressure. So we have components already developed for that. If you go to the Ladybug tab up here, you can see we have a component for cooling degree days, heating degree days, cooling degree average, heating degree average, and humidity ratio calculator. And I should give credit here to Chris Mackey. The humidity component is developed by Chris. He is a graduate student at MIT, and he is kind of an avid developer. He has these two components are developed by Chris too, and these two. And he modified so many components, and also he rewrote all the descriptions. So now descriptions are in pure English. You can read them. Like the ones that I had wasn't that good. So thanks to him, I think you can read these inputs and really understand them. So he rewrote it, and that's the main reason I updated all this component, because this version has a better descriptions for all the inputs. And as you see, I won't go and try all these components just for the sake of the time, but it's not hard at all. So you can see dry bulb temperature, you just connect dry bulb temperature from here to here. You have relative humidity, you connect it from here to here. You have barometric pressure, you just connect it from here to here, and it gives you an output. And then if you want to visualize it, you visualize it like this. If you want to have a kind of conditional statement, if you have a question, you just use that numbers to answer your question, whatever your question is. Here, I want just to talk about how Ladybug inputs are coded using these underlines. You know what is heating degree days, do you? I mean, I can't see your faces, yes or no. 0 or 1, like, okay, cool. So these components, basically what it does, it calculates cooling degree days and heating degree days, and this one calculates cooling degree average and heating degree hours. Do you know what is the difference between cooling degree days and cooling degree average? When do you use cooling degree average versus cooling degree days? Okay, so the main difference, so they're the same concept, right? But the difference is in cooling degree days, there are different methods, and this component has 2 different methods of using it. But like the traditional method is you average the values for the whole day, you average the temperature for the whole day, and then calculate the difference between that average temperature and the comfort or cross line, right? For the degree average, you do it for every single hour. So what will happen when you average it for the day, you don't see small fluctuations. So for example, if you have a single hour that the temperature goes to 16 and then it comes back to 24, right? If you do degree hours, you will see that 16 because it makes a big difference in that hour. But even if you go to 16, but the average of the day is still 22, and if it's inside the range, then the cooling degree days is going to be 0. And what's the use of that? If you're designing for a building that you have enough thermal mass, for example, right? So your building is not going to change as soon as something changes outside, right? So you're going to use degree days and you're fine. But if you're having a building like this all glass, no window buildings, which basically whatever changes outside in a single second you get it inside, then probably it's better to use degree average. Degree average will exaggerate the effect of degree days. But before going there, you can see some of the components, some of the inputs has an underline before, right? Some of them has underline on both sides, and some of them has underline only on this side. It's not only because I like underlines, but there is a meaning behind it. So if you see an underline on this side, on the left side, it means this is something that you should provide for the component, right? This is an input that you need to run this component. If you don't have this input, this component won't run. Then if you check on the other side and there is no underline, it means there is no value for this. But if there is an underline on this side, it means there is already a value inside, right? So if there is an underline here and there is no underline here, it means you need this, but there is no value. So it's an input that you need. It means, hey, you need this, but there is a value. This is default value, right? You don't really need this, but there is a value. It means it's optional, right? So underline here only on the left side means you need this. On both sides, you need it, but there is a default value. And these are the most dangerous inputs because there is a default value. Check the default value. Maybe you don't like this default value, so you have to change it. And for this one, it says like it's up to you. Sometimes it's a little bit confusing between optional and default values because almost all the optionals has a default value too. But like, I mean, it basically kind of like it's personal. Maybe somebody else thinks this you should call this default value. Just give you an idea. So just check this component, and this component doesn't have many inputs, but some components has like multiple inputs. So I just go here and I check this side, and I understand, okay, this is 4 inputs, but I really need only this one because there is no value here. For this, there is a value. And then what it needs is hourly dry bulb temperature. So I just connect hourly dry bulb temperature here, and it calculates the daily cooling degree days, daily cooling heating degree days, and all that values. And many components has a README here. And in README, I type panel. And in README, it usually gives you some stuff. Like it tells you if you have a default value, it tells you what are the default values you use. Sometimes if you have a mistake, it tells you that mistake. You know, so it's good always to read this README. So to get your stuff fixed. Okay, let's make it a little bit more interesting. I know like everybody is getting bored. Do it yourself. I have the placeholders for you. Go input, go fill this one, and then what we want to do, we want basically to select a part of the time, and we want to plot the data in 3D. You should be able to do it. This is 1:54. You have 6 minutes. Go for it, and you can cheat up here, but don't do it. So the first one, you need what? You need to open the file. You need to open a weather file here, and you need to connect it to an import weather file component. And then you need to connect global horizontal radiation. to this component or whatever you like. Let's all of us do the same thing now because I want to show some stuff. Connect this to here. It will load all the data, right? And then I said about global horizontal radiation. I found it here. I just connect it here. Boom. And now if I check, I have, me too. So, where's Rhino? Okay. Today Rhino and I doesn't have a good relationship. Time to break up. Let me get rid of this. So now what happened, I have all the data here, you know, but what if you don't want to do something annually? What if you want only to look at like summer or winter or some month? So there is another component is select data, or I call it Ladybug average data, which is select and average data. You can find it here, up here. What it does is it accepts annual data and then it accepts an analysis period, right? So you can say from month 6 to month 9, and as you see, everything is underlined, which means what? Which means everything has a default value, and default value is annual. So if I don't have any of these connected, so it means it will be from the 1st of January to 31st of December, right, for the whole year. And for one of, like, if you don't remember, it was like control going back, right? From months, 2 months, from hour. So from hour is going to be the first hour 1, 2 hour. Now what it gives me is like the selected hourly data, which is this time. Then you get average of the hourly data. Then you get average monthly. Then you get average monthly per hour. So like other Grasshopper components, you get multiple outputs, and based on your problem, you may use any of them, right? So for now, let's go and select the hourly data. So if I connect a panel here, what it gives me is it says there is a key, something there. Actually, this key helps you to understand what this thing is. It tells the first one is the location, then it's data types, then it's units. So Chicago, horizontal radiation, global. What hour per square meter is hourly data is to start from month 6 to month 9, day 1 to then day 30th, and first hour to the 12th hour. And this is cool. You have all the numbers, but probably you want to see it, right? So this component does this. It's a 3D chart, and you can find it here. So you can see we are walking from like, so we kind of touched base on all of this, except these two that I love New York and I still love New York. But and then we kind of used these two, and I showed you these three. So now we're moving here, right? Ladybug chart. So if you connect this selected hourly data to the chart, what will happen if you go to Rhino and zoom out? It will plot a graph. And what this graph means is all the data that you have, and it's kind of a shame that I don't have like values here, but it's something that I will add at some point probably. So what it does is it starts on this axis, which is the y-axis. If I go to the top view, if you don't know how to change between the views, again, like you have this right down here, or you can press Control Tab. So I went to the top view. Then you can type ZEA, which means zoom extend all, but probably you want to only zoom extend this view, so you say ZE. It will zoom extend, right? Press ZE. Or you can type, I think, Z and then type E. It should do the same. Or if you have something like, if you just get lost or zoom extend doesn't work or anything, the other way is go select a component, press this middle key, and you can see this one. It will zoom to the outputs of that component. So you go, I went here, press zoom. Right, again, I do it like, I get lost, push, it comes back. So now you have this data plotted in 3D perspective. Kind of looks cool. So from here you get every hour of the year from where you selected to the end, right? From here you get, like, on the y-axis you get every hour of the day. So hour 0, 1, 2, 3, 4 to 12. If I go and change to hour 12, if I do it 13, oops. Okay, let's fix this slider. We want a slider from hour 0 or 1 actually to 24. You remember how to do it? You double click here, 1 smaller than 24. Or if you want to do 1 to 24 and you want the default value to be 17, you do 1 smaller than 17, smaller than 24. And then connect this thing here. Delete this. And now if I change this, you see almost in real time, it changes the graph. So let's go to 24 hours here. I know you have like a cool looking graph, but okay, there are multiple things I don't like about this graph. The first is, okay, these colors, what these colors means, the color mean this values in whatever, but it's not the most useful thing for me. I want to see the hours that has radiation more than 600. Again, why? It depends on your design case, right? For now, we always assume we do it because of Rami, because of his project. So we want to find the radiations more than 600. I want to see wherever is more than 600, I want it to be red. So how can I do it? If I change the maximum of the legend to 600, everything more than 600 will be red, right? So if you check here, there is an input for the 3D chart. You don't get lost. Where I am here, 3D chart, right? There is a component that calls legend parameters. If you go backward, you will see this legend parameters. What legend parameters lets you do is basically play with the legend parameter, as its name tells you. So now I want everything more than 600 to be red. So I set the high bound to 600. I just double click here. If you're using a different weather file, probably you will have different values that you want to apply. Just check your legend and make an select a number that makes sense, right? Select a number on the higher bound. So I just type 600. And then I connect it to the high bound. And you see now, wherever is more than 600 is red. Then the next thing is, you know what? I don't like these colors. So what you can do is you can change the colors using these custom colors. For using the custom colors, what you need is a bunch of colors, basically. Like whatever colors that you want, you connect it. Let's go and say we want to have yellow and black, because yellow is radiation, black is not, for example. So let's go select your colors. Double click here, type color. White Honda? No, not me. No driving license. So you just type color swatch, and you get this swatch here, right? Then right click, change the color to black. Then copy paste or just insert another swatch. Just watch if you don't know how to do it. I right click, right? I go here, right click, and then I play with this. Now how to find yellow? Okay. This guy, I click here, it gets way easier. So what I did, I changed it, I think one is RGB. Yes, I changed it to RGB. So go here. So this color is now kind of yellow. Good enough. It is yellow. And select this thing. So now I have two colors, right? If I connect these two colors to these custom colors, it will change all the color set. If I connect the first one, watch what will happen. So what happened is actually changed to a color set that is the default color set, and this component changed to orange. Whenever a component changes to orange, it means like it's kind of complaining to you. There is a warning, but it's not that angry. If it changes to red, then you are in trouble, right? For Ladybug, it usually, even if you make like a mistake that is kind of critical, I usually don't give red because I think it's frustrating for people to see everything changes to red. So read this thing on the top. So I click on the balloon and it says you should connect at least 2 colors to custom color input. Because you don't connect 2 colors, it basically doesn't output anything. You see the output is orange line here. It means there is no data. If I connect a panel, hello, it's empty, right? What high bound? Because this component doesn't output anything. And then this component here, it says legend parameter is optional. So this component runs and checks, is there any input for the legend parameters? And it says no. This is okay, just go ahead. Use the default values. And for the default, what it does, for the high bound, it goes and it selects the maximum value that you have in the list. You know, whatever your value is maximum, it will be the maximum of your legend. Now if I connect the next color, which is yellow, everything should be fine. Let's do it. Everybody following? Everybody's fine? Yes, just there are different ways, right? One way is just right click here and reverse. It will reverse the list. So almost any input you can reverse the list. But if you don't know the reverse, what you do is you disconnect this, you disconnect this, you connect this first, you connect this second. Or if you are a good guy, you don't do this. You do a color collector, and then you connect this here, and you connect this here, and then you connect this thing here, right? And if you are the clean people in Grasshopper, which I'm not one of them, you select merge, and you merge these two together. So it's basically easier to read, right? So I know the output of this. The first one is the first one. The second one is the second one. And then I connect this thing here. Everything is basically data management, and there is no good and bad way. So if I want to give something to someone who doesn't know Grasshopper, merge is a good idea usually, you know, so people can follow. If you're handling the file to someone who can understand what's going on, it's fine, I think, to do it like what I did. Probably so many people disagree with me. But then you see, like what I was doing before was, instead of like doing color by color, I used a gradient component and I pushed some number, so it was giving me 10 different colors, and I was using that colors. This component is useful because you can right click here and change the preset. So as soon as you change the preset, it changes everything, right? So again, right click here, preset, change the color. So we talked about the legend parameters, color set. I think this is critical to know how to work with low bound and high bound and all this legend parameter, because this data does make sense if you control and present it in a way that makes sense. Else it's just bunch of colors, right? So if you want to do comparative studies, then you need to know what is the maximum number for all different values that you have. So what you can do, you can use a single legend parameter and connect it to different charts. We will see that. Does it make sense to you? So if you have like 10 different charts for 10 different cities, and then you want everything to have the same 600 as the maximum, you just create one legend parameter, you connect it to all the components. So far it's kind of useful, but still it's not there, because this is cool, but I want to show it to someone and say, you know what? You get all this average which radiation is more than 600 and Rami's design will close all the shadings. Are you happy with that? And that person say, okay, how many hours is this? Or I want to know when it closes the windows, what's going on with the wind. I want to use it for the natural ventilation. What about that? Or all that stuff. So one of the things that you can do is you can plot multiple datas at the same time. So what I will do here is I go and not only global horizontal radiation, but also select wind speed and connect it to the same input. I'm not sure if it will work like this. Let's do it if we should copy or we can just use it. Just press shift and connect it. Okay, it did. Here we go. What happened is if you do it like so, what I did was wind, I selected the wind speed, I pressed shift, and I connected to the same input. You will get something that probably the color will be the maximum color the minimum color that you have here. And why is happening? Because wind speed never going to be 600. Or if you have 600 something, you have a tornado. Or even worse, I don't know what's the word. But all this, right? All these graphs. So one way is to go ahead and disconnect this, maximum 600. As soon as you do this, every single graph will be set basically to maximum of what you want, right? But now I lost the point. I wanted to know like where the radiation is more than 600 and plot it on my wind, right? Gone. So how we can do that is a concept of what I call it conditional statements. Conditional statement is an input for the 3D charts, is an input for SunPass, is an input for windrows. And I think conditional statements is something that helps you really work with the weather data. And it's a simplified version of, or integrated version of what I did here. You ask a question about the data and you want the component to filter the data based on that. So you see here conditional statement, right? And there is explanation for that. So I'll just do it. It usually happens like when I do it, it's easier than saying what it exactly does. So I want to say to my component, show me the average that radiation is more than 600, right? I connected radiation as the first list to this component. How do I know that? I just remember. If you don't remember, you can just look to the output here and it tells you, right? The first one is radiation, global horizontal radiation. Or if you think that's not a good way, you can use this component that separates all the data and connect all your data here and then check the string output. The first branch, okay, how many of you watched the video for the data trees? 3? Okay. Watch it later because this is something, I mean, in this class you'll be fine, but like when it goes, you won't be fine with Grasshopper in general. And in next class probably you will have some issues if you can't understand what is a branch when I say a branch. So the first one, the first whatever 0 shows me like it's radiation, and the second one is wind speed. How conditional statements work is it's basically you can type a standard Python condition, right? For example, you should be able to type and say radiation, oops, sorry. So you need a panel, right? Radiation bigger than 26, right? But then you should know all the keys, like you should know radiation, temperature, wind, you know, all that stuff. And it's a little bit hard every time when you connect something new, you go and type something long. You can make mistakes, then I have to catch all that mistakes. Basically, I should be Google again, like for you. Do you mean this? Do you mean that? So to make it simple, A represents the first list, B represents the second list, and it goes to Z, right? So you can connect, I don't know, 28 different lists, and it works that way. So for example, if I want to say radiation, which is my first list, more than 600, I type A bigger than 600. and I press enter. So now if I connect this conditional statement to this component understand when I say A, I'm talking about the first list. It goes inside and find all the points more than 600. Nothing happened though. But something happened. So what happened is it found all the points, and it's actually the points are there, but I made the preview off. I intentionally did make the preview off of this output because I think sometimes it's really confusing. So if you want to see this, just double click, type point, and connect this output to here. So you can see all this. So these are the points that that basically the conditional statement is satisfied. Bless you. And now I can zoom in on my wind. I can say, okay, not many hours, like just visually, right? But the good way of doing this instead of what I'm doing is this one gives me the hours of the year that actually this statement is applied. In the hour of the year 587, this thing happens. Everyone can follow. So what I'm doing here, I have a bunch of data. I plotted all the data. Fine, right? Now I want to play with the data. I want to say, show me when this thing happens. And I want to use it to run some analysis or just have some conclusion. So I applied a data here, and then this one gives me the conditional points, which basically is good for visualization. I can visualize. And this one gives me the output for the hours of the year that conditional statement applies. And there is another component here in extra, which basically generates, the other one. It takes the hour of the year. Making a mistake 2 times. Here. It takes an hour of the year, and it outputs the date for you. So it's 25th of January, 11/12. So this is all the hours that this conditional statement is applied. But still, this is not the best kind of visualization that you want to have, right? The other thing that you can do is you can go here, and there is an input called vertices. Can you see that? So what you can do, double click here, type Boolean toggle, set it to true, and connect it to call vertices. And what it does, and go ahead and disconnect this point or delete this. So what it did, it basically called all the vertices that are not satisfying what I want. A better visualization is usually like do it the other way. So you do A is smaller than 600. So it basically calls the time that you have. So if you want to have a nice graphic presentation, you can go options, and then you can wait. And then there is a display, appearance, color. Why there is, hello. And then background, and then make it black. And then if you want, this mesh doesn't have the lines. What you can do, if you go here and press Control M, it also shows the lines. I mean, you can play with this. So now the lines are black, which is basically the color from here. So where to change that colors is here, up here. I clicked on this. I can make the colors red, which is kind of the default, or I can make it orange. But I don't like that color, so I make it black. And then you can go and change the background colors. Again, I show you how to do it. Options. Here, appearance, colors, and then make it white. Oops, okay, and okay. So it kind of gives you a nice graphic that you can share with other people. But this thing is actually 3D, right? Control M. Control M. It should be somewhere up here too. Display here. Preview mesh edges. I just press Control M. So now you can see this. I said, do you remember what was my question? I said I want to know when I have radiation more than 600. Do I have enough wind speed? Go ahead. What's the question? Why? What did you get? The mesh? Do you have the preview of the component off? Preview? Okay, I'll come. Is it a conditional statement that's like, what is the maximum of your radiation? So yeah, so there is no average basically which satisfies your condition. So you get 0. Let me check in a second. Let me talk about like how you can do multiply statements here. So I said I want when the radiation more than 600 and the wind speed is enough. And let's say enough wind speed for this case, let's say, is 2 meters per second, right? How to do that is, instead of doing this is a cool graphic, but it doesn't give you real numbers for the question that we had. So I just remove these call vertices. I just remove this. It gives me everything, right? I go here and I say when A is more than 600 and, just type and, no next line, nothing, just in the same line, right? A bigger than 600 and B. Why B? Because it's the second list that you have. And B is bigger than 2. And then press OK. And now you can do call vertices, but like go point, I think, is helpful. So it shows you the points that this condition is satisfied. So you have 443 hours of the time that we selected. How many values did we had here? How do I know how many values I had in the input? I go here from this component and check the length of the numbers. So out of 2,900, 28 hours, you have 443 hours, which is good. Is it good, Rami, or not for your design? So you see, this is how you work. You have an idea, you want to find the answer, and this is how you play